All right, welcome to the semester. We're going to start off with a chapter here, section 1, linear equations. It should be a nice little review for you. So we're just going to jump right in. When you solve a linear equation, the goal is to get the variables on one side, the numbers on the other, so you can get that solving for this linear equation essentially means what value of x is going to make my statement true. And that is our target. That is our goal. So we have to figure out when we solve for x, what value of x is going to make our statement true. So we solve for x, get that x by itself. Let's go ahead and get started. Distribute this 3, because the first thing you want to do is simplify both sides, then collect those x's. So I have 3 times 2 will give me this 6x minus 12. Now this is 7 minus that set of parentheses. The fact that that minus sign is touching those parentheses, that's how you know you're going to distribute it. So I really have 7 minus x minus 5 on the right side. Over here on the right side, I also have like terms, so I'm going to combine those and get those together first. So I now have 6x minus 12 is equal to a 2 minus x. Now combine those like terms. I'm going to add x to both sides. That cancels, and I'm left with 7x minus 12 is equal to 2. When you add 12, because the goal is to get that x by itself, 7x is now equal to 14. Divide both sides by 7, and we get x equals 2. Awesome. Just as a reference, when you have an actual number as your answer, that is called conditional. So I don't really care if you know that so much as in your My Math Lab homework, they ask for what types of equation these are. That way you know. What I'm more concerned about is that you can come up with the answer. If I have a problem like this, what do we have in this problem? Dun dun dun, fractions. So, do we want to mess with fractions? No, no one likes to deal with that. So, because we don't want to do problems with fractions in them, we want to eliminate the fractions. How do you eliminate the fractions? Find a least common denominator, to eliminate fractions. Now, whenever I'm looking for that common denominator, I want to look at my existing denominators and what goes into all of those. 12. Good, because 3, 2, 4, and 3 all have a 12 as a common denominator. So I'm going to multiply this entire fraction by a 12. Now when you do that, you are going to distribute that 12 to each term. So essentially what you're doing is you are taking 12 over 1 times a 2x plus 4 over 3 plus 12 times a 1/2 x is equal to 12 times a 1/4 x minus 12 times 7/3. Ooh, I'm running into my deal. And when you do that, this 3 goes into this 12 4 times, so I really have 4 times 2x plus 4. No more fractions. And that's the goal. 2 goes into 12 6 times, so I'm left with a 6x. 4 goes into 12 3 times, so that leaves me with a 3x, because I take 3 times 1, minus 3 goes into 12 4 times. I take 4 times 7, which gives me a 28. Now I have a sweet little linear equation that's easy to work. When you have fractions, eliminate them first. Once you do that, then it's smooth sailing. Okay, then just solve this out real quick. So I have 8x plus 16, because I distribute the 4, plus a 6x is equal to a 3x minus 28. Combine your like terms on the left. So 14x plus 16 is equal to a 3x minus 28. That's an equal sign in the middle. Get your variables together. So I now have 11x. I'm going to go ahead and subtract the 16 at the same time just to expedite the process. So negative 28 minus 16 is going to give me that negative 44. Divide both sides by 11, and x is a negative 4. Again, if I come up with a number, then it is called a conditional statement. The goal on these problems, anytime you see fractions, you automatically want to eliminate them. Good, let's do more. All right, let's take a look at this one. So, same thing, go ahead and distribute. So now I have a negative 2x minus 8 plus 3x is equal to an x minus 8. When you combine your like terms on the left side, look at what's happening. If you have the exact same thing on both sides of the equation, that means it does not matter what you put in for x. Everything is going to work. And remember, our ultimate goal here is to determine what values of x are going to make my statement true. And if all of them work, this is called an identity. The other way you could look at this is if you subtract x from both sides, then they cancel out and you're left with a negative 8 is equal to a negative 8. When you have the exact same number on both sides and no variables, that is why this is called an identity, because it's the same no matter what you plug in. When you have an identity, then any value you put in for x. So your solution to this problem is going to be all real numbers. You can make the symbol for all real numbers with the R with a double line. That is the same thing as writing all real numbers. Here is our last type of problem. Let's see what happens here. When we distribute that 3, we get a 9x minus 3 is equal to 9x plus 7. Notice what's happening. When I subtract my 9x, they are eliminated, and I have negative 3 equals 7. Is there any value I can put in for x that's going to make negative 3 equal to 7? No, sirree. So this is a no solution. That is your answer. The type of equation this is a contradiction. That's because there's absolutely nothing you can do to make that statement true. So there are 3 types of equations that we have looked at. The conditional, which is an actual answer, the identity, which is all real numbers, and the contradiction, which is no solution. Cool. We've just got a couple more examples, and those are solving for a variable. So you can solve linear equations to find a numeric value for that variable, or you can just arrange problems so you can get that variable by itself. For this problem, we want to get the t by itself. So when we look at this, we are going to divide by the p and the r, and whatever you do to one side, you have to do to the other. Now, the beauty of these problems is you are just literally rewriting what you did. So I have an I, which that's an I, it's hard to tell, divided by PR is equal to T, and that's my goal. This is actually a simple interest problem. Interest is equal to principal, rate, and time. The other thing that's happening with these problems, and you need to make sure that you pay attention to, is you need to keep the case. If it's uppercase, keep the letter uppercase. If it is lowercase, keep it lowercase. That is important because these are actual problems where you need to make sure that you are keeping the value of what that variable is. Cool, let's do one more. Okay, now let's take a look at this one. Again, we're solving for a variable, but notice what's happening in this problem. we have a p on the left and a p on the right for my problem. When you want to solve for a variable, you have to collect those values and get it by itself. So the first thing that I'm going to do is I'm going to add a p to get them together. So I now have a is equal to p rt plus ap. Now when I have them together and it's in common, you can factor. What? You thought you were rid of factoring? Not yet. Now you can factor out that p because it's in common, and that leaves you with p on the outside factored out as a greatest common factor, and then the rt plus 1. Don't forget, p divided by p is 1, so you have to keep that. Now still, my goal is to get that p by itself, so p is multiplied by that rt plus 1. Just divide it. The beauty of solving for a variable is you're just rewriting what it is that you're doing. So capital A, remember to keep the case, divided by RT plus 1 is now equal to P. Pretty cool, right? So let's sum up what we've talked about here. There are 3 different types of equations and solutions. How you get there is the process, but you end up with either a number, which is a conditional. Remember, I don't care if you know what type it is, simply what that answer is, except for my math lab. All real numbers, which is an identity, and no solution, which is a contradiction. Now, the quest to getting there is sometimes the challenge, and remember that if you have fractions, you want to make sure that you get that common denominator and then eliminate those fractions. Much easier to solve. Okay, enjoy your linear equations.